All right. Hey, Amanda, ignore that. This is K2, proving triangles are congruent by SSS and SAS. So I'm going to be switching back and forth from the Ixl to my drawing board here, just so that you can see how we could kind of use our diagram here to mark it up. So what I would probably end up doing is maybe copying down the diagram and marking it up according to what it says in the proof. So here we are told that V is the midpoint of SU. So if V is the midpoint, then that means that SV and UV is congruent, because a midpoint means that it cuts that in half, which you'll see here as SV is congruent to UV, because that's the definition of a midpoint. Then we are told that V is the midpoint of RT, and this means that RT is congruent to TV. So this is congruent to this. Now what we have here is 3 sides for each of these triangles that are congruent to each other. So when you have 3 sides, that's SSS, side, side, side. Now here we have that H is the midpoint of FG. So again, I'm going to copy this diagram here, just so we can mark it up. So we have that EG is congruent to EF, which is already marked for us. FH is congruent to GH, and that's because it's a definition of a midpoint. And then we have that EH is congruent to EH because of the reflexive property, because they share that side. Again, we have 3 sides that are congruent to each other, therefore this is also SSS. You can kind of get a handle of this just by looking at your proof. When you're only given sides, that must mean that this would be SSS. So, for example, G is the midpoint of FH. That means that this is congruent to this. HG is congruent to GF, which is given over here in statement 4. Then FI is congruent to GJ, so this would be congruent to this one. And FG is congruent to GH, which we already know. And basically let me start over. Sorry. Let me just get the diagram so you can see this a little better. So we have FI is congruent to JG, or GJ, whatever. GI is congruent to HJ. And FG is congruent to GH. Again, we have 3 congruent sides to each other, so this is also SSS. Okay. Now here we have to now give a reason and not the actual proof as to why these 2 are congruent. So again, I'm just going to copy this. I'm sorry, this is just the easiest way that I could probably copy the diagram instead of having to redraw the whole thing. So just bear with me. Okay, so we have that triangle EFH is equilateral. So EFH, okay. We have that angle HEI is congruent to GFH. We have that EI is congruent to FH. Wait, EI is congruent to FG, sorry. And then we have that EH is congruent to FH. So now let's see the reasoning as to why those 2 would be congruent. Now we were told here that triangle EFH is equilateral. That means that all the sides would be equal. So what we can say here is that it's the definition of an equilateral triangle because, whoops, oh goodness, sorry about that. This is the triangle that they were talking about, EFH. So that means that all of those three sides there would be equal, meaning that EH would be equal to FH. So that's why I put a definition of equilateral triangle. Okay, we have here that angle, or rather S is the midpoint of QR. Again, I'm just going to go ahead and copy this diagram just so that you can see exactly how everything works. Let's make this a little bigger. Okay, we have S is the midpoint of QR. Okay, that means that SR and QS would be congruent because it's the midpoint. We have QR is perpendicular, so QR is perpendicular to PS. And if it's perpendicular, that means that this must be 90 degrees. Angle PSQ and angle PSR are congruent. Now let's see why. Now we know that they're congruent because they're both 90 degrees because they were perpendicular. So they're both perpendicular, they're both right angles. That must mean that all right angles are congruent would be the reason. QS is congruent to RS, which I already made congruent, and that's because of the definition of midpoint. Then PS is congruent to PS, and that's the exact same side because they share that side. And whenever you have a statement like that, that's when one side is exactly the same as the other. Think of a reflection. That's the reflexive property. Reflection, reflexive. You know, when you look at your reflection, you're looking at yourself. That's kind of the way I look at it. Now, there's two. There's congruence and equality, and that depends on the symbol that they use. They have the congruent symbol and not the equal sign. So that would mean that this is the reflexive property of congruence. Now here we have ST is congruent to RS, QR is congruent to QT because this is given. QS is congruent to QS, which is itself. So again, this is the reflexive property of congruence. And therefore, these two triangles would be congruent because, and I would put here SSS. And if you look at it, it's because we are only given sides. We're not given any angles. So that's the only way that they could be congruent, is because all the three sides here are congruent to each other. Okay. GJ bisects angle HGI. So this one I may want to mark up. Let's get this diagram here. All right, so JG bisects angle HGI. So if it bisects, that means that this angle must be the same as this angle, because that's the definition of an angle bisector. GH is congruent to GI, and that's given, that's already marked for us. Now it tells us here, angle HGJ is congruent to IGJ. And I already have that marked, and that's like what I said, that's the definition of an angle bisector. GJ is congruent to itself, GJ, so that is the reflexive property of congruence. Now, if I look at my diagram, right, that's this right here, the JG, or GJ, you can see that in this one triangle we have side, angle, side, side, angle, side. So that's why those two triangles are congruent, by the side, angle, side. All right, this will probably be our last one. We have here, WX is congruent to UV, and that's a given statement. So, because I always look up here to make sure. So here we would write given. I passed it. Then UX is congruent to VW, also a given statement. So once more, we would write given. UW is congruent to UW, again, the reflexive property. The only thing that we have given here are sides. And again, if you want to see how that works, let me show you the diagram. And again, I like to mark everything up. It just makes it easier for me to understand. So I always recommend to draw out your shapes. So WX is congruent to UV. UX is congruent to VW. And UW is congruent to itself. So what I have here is side, 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 side. So these triangles are congruent by the side, side, side. Whoa, what do you mean no? What did I put? Oh, I put reflexive property of equality, but you should know it's congruence. Let's just do one more just to make sure. Okay, let me copy this diagram. So you got to be careful, especially with these, because even if you get one thing wrong in the proof, it'll set you back, as you can see. Okay, so we have here that T is the midpoint of QS. So if T is the midpoint, that means that QT is going to be the same as TS. T is the midpoint of PR. So if T is the midpoint, that means that RT is going to be the same as TP. Then here it tells you QT is congruent to ST, which is what I've already marked, and that's because of the definition of a midpoint. And PT is congruent to RT, which is for the same exact reason. That's the definition of a midpoint. Now angle PTS and angle QTR. So PTS is congruent to angle QTR. And that's because these are vertical angles. Remember that vertical angles, it's like when you have an X, the angles in front of each other are going to be congruent. So here we would look for vertical angles. And then as you can see, this is side angle side because we have a side angle side and then a side angle side. Let's see if we can do this without the diagram. We have VY is congruent to UY, that's marked. WY is congruent to XY, also marked. And then angle UYX is congruent to VYW, which is also vertical angles. So we would have a side, the angle, and the side, side, angle, side. So that would make this side angle side theorem. Last one, just to make sure that we get to that 85. I want to make sure I got this all right, so I'm going to copy this diagram. Okay, here it says that Q is the midpoint of PR. And as you can see up here, that is a given statement. Next, what I'm going to do is I'm going to mark up this diagram. If Q is the midpoint, that means that PQ is going to be congruent to QR. Oops, I don't know, sorry, let's put 3 because we already have 3. So now if you look here, it tells you QS is congruent to QT. It's not written here, but it's given in the diagram. It's already marked for you. So this is also a given statement. So if it's whether it's written out or whether it's drawn in the diagram, that's a given. RT is congruent to PS, also given in my diagram. Then PQ is congruent to QR, and that's what I've marked up here, the 3 lines. And that's because since Q is the midpoint, that means that either side would be congruent. So this is the definition of a midpoint. And as you can see from the diagram, what we have here is side, 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 and side, side, side. So these 2 triangles would be congruent by SSS. And that's Ixl K2.